Hey everyone, this is going to be our second lesson on using the factoring method. In this video, you will learn how to solve a quadratic equation using the factoring method when a doesn't equal 1. Follow along with your note sheet and take some notes. Remember that when we solve a quadratic equation, we are looking for the x-intercepts of the function. So the quadratic in the example has two solutions, x equals 0 and x equals 4, because this is where the parabola crosses the x-axis. So we're going to solve this quadratic using our factoring by grouping method. The first step is to make sure that the quadratic is written in standard form, which it is. All of our variables and our constants are on the same side, and the equation's equal to 0. When I look for a greatest common factor, I see that I don't have one. So now I'm going to factor what I've got. In order to do that, I need to find the two numbers that multiply to make a times c, which in this case is 7 times negative 6, which is negative 42. I then need to find those same two numbers that multiply to make negative 42 also have to add to make positive 19. All right, so I can use my calculator, just like we did in the last video, to see what numbers go into 42. When I look at my equation, I notice that a times c is negative, and that means that one of our numbers is going to be negative. So I'm going to take negative 42 and I'm going to divide it by 2, and I end up with negative 21. 2 plus negative 21 is negative 19. I don't want negative 19, but I do want positive 19. So just switch the number that the negative is on. Is negative 2 plus positive 21 19? And it sure is. So our two factors are negative 2 and positive 21. So I'm going to take this 19x in the middle and I'm going to split it up into two pieces. I've got negative 2x plus 21x. Okay. And then I'm going to bring down my negative 6, that was c, and my 7x squared. Now I've got four pieces and I can factor by grouping. I'm going to put parentheses around the first two terms and parentheses around the last two terms. And I need to look at 7x squared minus 2x and see what I can factor out. There's nothing that goes into 7 and 2 besides 1 because they are relatively prime, but both of those terms have an x in them. So I'm going to divide out my x, and I'm left with 7x minus 2. So the second piece of my grouping must also have 7x minus 2. So I look, what do I need to divide out of 21x to make it equal to 7x? 21 divided by 3 is 7, so that's my number. So I put a plus 3 in front. My factors then are x plus 3 and 7x minus 2. And I set those equal to 0. So x plus 3 has to equal 0, and so does 7x minus 2. I'm going to start with the easy one first. I need to solve for x, so I subtract 3 from both sides, and I end up with x equals negative 3. So there is one of my solutions. I come over to the two-step equation. I've got to add 2 to both sides. And I have 7x equals 2 I divide by 7, and I'm not going to freak out because I have a fraction and 7 doesn't go into 2. It's okay. Leave your answer as the fraction. So this quadratic has two solutions. Its solutions are -3 and 2 over 7. So that means that this parabola has two x-intercepts, one at -3 and one at 2 over 7. So let's do it again. In example number 2, I don't have everything on the same side. My quadratic isn't written in standard form yet. So I draw my dividing line, and I see that I need to move that +6 to the other side of the equation. I do that by canceling out with a -6. Now I've got 0 on the right, and I'm left with 12x squared minus 14x minus 6 equals 0. So then I'm going to look to see, do I have a greatest common factor? And I do. All three of these numbers are even, which means that they are all divisible by 2. So I'm going to take the 2 out. And if I divide 2 on the other side of the equal sign also, that 2 can just go away. So I'm left with 6x squared minus 7x minus 3 equals 0. So I'm ready to factor by grouping. I now have an a value of 6 and a c value of -3. So I'm looking for two numbers that multiply to make -18. Those same two numbers must also end up adding to equal -7. So numbers that multiply to make -18. -18 and 1, but when I combine those, I'm not going to get -7. What about -9 and 2? Let's check. -18 divided by 2 gives me -9. -9 plus 2 is -7. So I've got the two numbers that I want. Those two numbers are -9 and +2. So I'm going to take my -7x and I'm going to split it up into two pieces. -9x and +2x. I bring down my -3 and I bring down my 6x squared from the front. Now I'm ready to factor by grouping. I'm going to put my parentheses around my first two terms and my parentheses around my last two terms. And I look at the first two terms. What can I divide out of both 6x squared and -9x? What's my greatest common factor? Both of those numbers are divisible by 3, and they are also divisible by x. So I'm going to take out a 3x. 6 divided by 3 makes 2, and I bring down 1x. -9 divided by 3 is -3. Oh, hey, check it out. That's exactly what I have in the second parentheses. Now be careful. If I've got 2x minus 3 in the second set of parentheses, I still need to add something here. So what's the invisible number that's multiplying 2x minus 3? 1. So my factors are 3x plus 1 and 2x minus 3. I set those equal to 0, and now I'm ready to find my intercepts. I set 3x plus 1 equal to 0, and I set 2x minus 3 equal to 0. Both of my factors are now two-step equations, So I'm going to subtract 1. 3x equals -1. And divide by 3. And again, fractions are not scary. X equals -1/3 is one of your solutions. For the second piece, I add 3 to both sides. 2x equals 3. And then I divide both sides by 2. Fractions are definitely not scary anymore. X equals 3/2. So your two solutions of -1/3 and 3/2 are the locations of your two x-intercepts for this quadratic equation. Example 3 is now a little more complicated. I've got 2 things on the left and 2 things on the right. I still need to move everything to one side. Your general rule is you want to keep that x squared term positive, or in this case the ax squared term. So I'm going to move the 3a and the -5 over to the other side. So I'm going to subtract 3a from both sides. I have 6a squared plus 17a gives me that -5, and then I add the 5 as well, so that I have 6a squared plus 17a plus 5 equals 0. I don't have any greatest common factors, so I'm ready to set up my factoring by grouping. I need to find 2 numbers that multiply to make a times c which is 30. And those same 2 numbers need to add to make 17. 6 times 5 is 30. But 6 plus 5 gives me only 11. 30 and 1 go into 30. But 30 plus 1 does not give me 17. 10 and 3 combined also won't give me 17. So how about 15 and 2? 15 times 2 is 30. 15 plus 2 is 17. So I'm going to take that 17a and I'm going to rewrite it as 15a plus 2a. And I'm going to set that equal to 0. So I'm ready to start factoring by grouping. So you're going to put parentheses around the first 2 terms and the last 2 terms. In the first 2 terms, I can definitely divide out an a, and 3 goes into 6 and 15. So I can also divide out a 3. So I'm going to take out 3a. 6 divided by 3 is 2, so that leaves me with 2a. 15 divided by 3 is 5, and the a there cancels out. Oh, hey, this is kind of like the last problem, because I already have a 2a plus 5 on the other side. So I'm multiplying the second 2a plus 5 by 1. So my 2 factors are 3a plus 1 and 2a plus 5. And that product equals 0. So now I'm ready to actually solve for my 2 intercepts. 3a plus 1 equals 0, and 2a plus 5 equals 0. So I draw my dividing line. I subtract 1 from both sides. 3a equals -1. I divide both sides by 3 and A equals negative 1/3. There's x-intercept number 1. On the second side, I'm going to subtract 5 from both sides. I end up with 2A equals negative 5. And then divide both sides by 2. And A equals negative 5/2. X-intercept number 2, those are my two solutions. All right, one more example. This one's going to be easier because I've got a perfect square in the front and a perfect square in the back. My quadratic is already set up in standard form. I've got my x's and numbers on one side and 0 on the other. 9 and 25 are relatively prime. No number goes into both of them. But now I can do step 3 because I've got two things separated by a minus sign. Are they perfect squares? Heck yeah, they are. 9x squared is 3x times 3x. And 25 is 5 times 5. So I know that when I have a perfect square in the front and a perfect square in the back, separated by subtraction, my factors are the square root of the front plus the square root of the back and the square root of the front minus the square root of the back. Now I've got my two binomials. They are set equal to 0. So I'm going to solve them. I draw my dividing line. In the first one, I'm going to subtract 5 from both sides. 3x equals negative 5. And then I divide both sides by 3. X equals negative 5/3. And that one is done. So one of my x-intercepts is negative 5/3. In the second one, instead of subtracting 5, I add 5 to both sides. And I end up with 3x equals 5. Divide by 3. And x equals 5/3. So my two x-intercepts are opposites of each other. One is at positive 5/3, and the other one's at negative 5/3. Now it's your turn. You've got 3 practice problems. Complete them, and make sure to have them checked before moving on. Good luck.